Hello everyone, hope you guys are having a good time. A big thanks to Data on Kubernetes community for giving us the opportunity to share the platform with you guys. I am Kamol Hasan with you. I'm currently working at AppsCode and I'm also one of the lead engineer on KubeDB project. With me, we have Fahim. Fahim.
Hello everyone, I'm Fahim working at AppsCode. I'm also one of the lead engineers on the KubeDB project. Today we'll be talking about auto-scaling stateful set workloads in Kubernetes. Kamol, the floor is yours.
So, what is a stateful application? As the name suggests, a stateful application saves its state data to a persistent volume. The state data can be like session, transaction, etc. When it sends its response to client based on its current state, which is calculated from its previous state. So how can you implement stateful application on Kubernetes? To run stateful application on Kubernetes, we can use stateful set. Stateful set is a K-test object used to manage the stateful application. The stateful set controller has the following feature. It provides unique network identifiers such as unique pod name or pod specific DNS address. And it also provides stable and persistent storage, which can persist data even the pod got killed or restarted. It also provides the graceful deployment and scaling. It also supports the rolling update. So when you perform any changes to the stateful set object, it updates one pod at a time to prevent downtime. So why we need auto scaling on a stateful set? To meet the demand, we need to scale our stateful application. It can be horizontal or vertical. During the horizontal scaling, we can scale up or down the number of replicas on our stateful set, or during vertical scaling, we allocate new resources such as CPU, memory, or storage. Rather than doing it manually, we can automate the full procedure and it will give us some benefits, such as faster response time with variable loads. So when the scaling operation happens as soon as the cluster changes its load, it provides better performance and fault tolerances. It provides high availability. It reduces cost because it will only use the resources that is necessary, no redundant resources. It saves lots of time because you no need to monitor it continuously. Databases are good example of stateful application. For this, we will only talk about the databases in the rest of the session. So how can you implement auto-scaling? So when it comes to auto-scaling the stateful set, the first thing that we will consider the HPA, the horizontal pod autoscaler. But there are some issues with HPA and databases, such as the challenge when you scale up happens, there is no way to confirm the new pod joins the existing pods and it is sharing the load with other pods. So the ideal way of doing it is given here. You can take a look at it. We have, and while scaling down, we have no way to make sure that no data is lost. And if the cluster is on primary standby mode, we need to make sure that the standby pod get scaled down first before the primary. And we need to move data to different pod if necessary. If there is any ongoing task, we need to complete it, either terminate it or move those tasks to different pod before shutting down the pod. Once the pod is gone, we need to clean up the underlying PVC. So in future, if there are any scale up happen, so we need to make sure that there is no corrupted data on the pod. So here is the ideal way of doing it. You can take a look. How can we achieve it? With all this, we cannot directly rely on the HPA with databases. So there is another way of achieving it, the vertical pod autoscaler, the VPA. The Fahim will explain whether we can achieve the auto-scaling with VPA or not. So Fahim.
Thanks, Kamol. Let's jump into the challenges of automating the vertical scaling process. The first challenge is to determine the resources to scale. If the application is consistently using lower resources than the requested amount, we should scale down the resource. On the other hand, if the application is consistently using higher resource than the requested resource, we should scale it up. So first, we need a resource to recommendation that we can act on. To solve this, we can actually use Kubernetes vertical pod autoscaler, VPA, to generate the recommendation. VPA has three components: recommender, updater, and admission controller. We can turn off the updater using VPA specification so that the VPA doesn't update the workloads. We'll explain later why we cannot use the VPA to update the workloads. So we only need the recommendation generated by VPA to auto-scale our workloads. The next challenge is to determine when to trigger the auto-scaling. The resource recommendations may change frequently, but we shouldn't scale every time a new recommendation is generated. To solve this, that auto-scaler should have some threshold, like the percentage of difference between the requested amount of the resource and the recommended amount of the resource. If the generated recommendation crosses the threshold, then the autoscaler should trigger the scaling operation. Next thing is the manage restart. Stateful set workloads like database need managed restart while scaling. For example, in database with primary standby architecture, it generally requires restarting all the standby nodes first, and when all the standby nodes are restarted, the primary steps down and one of the standby nodes becomes the new primary. Finally, the previous primary node is restarted, so this order needs to be maintained when we restart the database as a part of the auto-scaling process. This is where we cannot use VPA directly to update the workloads, because the VPA won't be able to do the managed restart. To achieve this, we can actually use a CRD. The responsibility of this CRD will be to do the necessary tasks like managed restart for the vertical scaling operations. When we have recommendations to scale, the autoscaler can create an instance of this CRD to scale the workloads. The next challenge is to autoscale a group of workloads together. A group of workloads might need to be autoscaled together. For example, generally in sharded databases, each shard is represented by one stateful set. But all the shards are treated similarly by the database operator. But each shard stateful set may have its own recommendation. So we need a way to scale them all with the same recommendations. To solve this, we can merge all the recommendations and use the merged recommendations to scale the workloads. For example, if there are two shards, they generate recommendations of their own. We can actually take the maximum recommendation and trigger the scaling with that. So all the stateful set will scale similarly with the same resources. The next challenge is to handle the failed scaling. An auto-scaling operation might fail for several reasons. For example, while restarting the database nodes, they might not join back in the cluster due to some failure, or some other database failures, the scaling operations may get stuck. So when an auto-scaling operation fails, the database may not be in a usable state. The autoscaler should know this and shouldn't perform any subsequent operations until the failure is resolved manually or automatically by the operator. So we can solve this by using a CRD that we have explained before. The CRDs for explaining, we can easily solve this by marking the scaling operation as failed. When the autoscaler tries to trigger the autoscaling operation, it will first check if there's any failed operation or not. If the last operation was not successful, the autoscaler won't trigger the autoscaling operation. The next challenge is to handle the application maintenance. When the application is going through maintenance, the autoscaler shouldn't trigger any autoscaling operation. If an autoscaling operation runs during maintenance, the application might break. We can have an automated way to pause the autoscaling. Like if we use the CRDs that we have explained before, we can use CRDs for each maintenance operation, such as horizontal scaling, vertical scaling, reconfiguration, restart. There are many such maintenance operations. We can use CRD for them. It can be single CRD or separate CRD for them. So we can easily check any ongoing maintenance operation using those CRD instances. The autoscaler will check the CRO's status and won't trigger any autoscaling operation if any of them is currently running. So by this, we'll know that currently there is some maintenance operation ongoing on the database. Thank you guys for joining us. Please feel free to reach us with any questions.
Thank you, everyone.